Hi everyone, I'm Jana Ibrahim and let's discuss about Zener Diode. Zener Diode is a specially designed diode. It works in the reverse bias region. But a normal PN junction diode cannot work in reverse bias. Zener Diode is a highly doped diode. The highly doped PN junction in Zener created the Zener breakdown effect, which allows Zener to work in reverse bias. To understand the working principle of Zener Diode, let's discuss about Avalanche Effect. When a PN junction in reverse bias, the depletion layer becomes wider. When the reversed bias voltage is increased gradually, the depletion layer becomes more and more wider. During reverse bias, there are hardly any current flow from the P side to the N side, but there are a small amount of current called the reverse saturation current that constantly flowing, and this current is due to the minority carriers. If we keep on increasing the reverse bias voltage, there is hardly any change in this reverse saturation current. However, there is a limit on the voltage that can be applied in this reverse bias condition. If we apply the voltage beyond the maximum limit, the diode will enter the breakdown operation region. In this region, suddenly there's a lot of current flowing in reverse direction, and this effect is called the avalanche effect. The width of the depletion region will increase, and this will increase the immobile ion at the PN junction. And because of that, the electric field becomes stronger at the PN junction. Due to the strong electric field, the minority carriers at the depletion region get accelerated, and they can move more quickly. Once the applied voltage reaches the breakdown voltage, then the charge carriers receive sufficient kinetic energy such that they can knock off the bound of the electron valence of the silicon atoms. And because of this phenomena, instead of having one free electron, we will have two free electrons. Due to electric field, charge carrier will collide with more atoms and create more free electrons. Hence, the number of charge carrier in the depletion layer increased drastically. And we will see a sudden jump in the reverse saturation current. This effect is called the avalanche breakdown effect, and the voltage after which it occurs is called the breakdown voltage. For normal diode, its region of operation must be avoided. Zener Diode can work in reverse bias region because it has different breakdown mechanism. Zener breakdown occurs at relatively low reverse voltage than the avalanche breakdown voltage. Unlike the normal diode, the N-type and P-type of Zener materials are heavily doped, which results in a narrower depletion layer. If the P and N material is heavily doped, it means that the number of charge carrier in both materials are more than the normal diode. Now, when the electron diffuses from N side to P side, it will recombine much faster and much nearer to the PN junction itself. And because of that, the small depletion region will have more numbers of immobile ions compared to the normal diode. Hence, the Zener will have higher electric field at the depletion layer compared to the normal diode. Therefore, many charge carriers are created at the narrow depletion layer. And suddenly, there are more current flowing in the reverse direction. And this is called the Zener breakdown effect. The voltage at which the Zener effect starts is called the Zener voltage. From the graph, it can be observed that the Zener voltage remains constant even though when we increase the supplied voltage. Only the Zener current will increase. And due to this special property, Zener diode is used as a voltage regulator in many applications. Let's wrap up our topic on Zener diode and its operating region.